Hi girls. So today we're going to look at a case study of extreme weather in the UK. So you need to know the causes and effects of an example of extreme weather. So we're going to look at a place called Cumbria in the UK, and particularly at a town called Cockermouth that you can see in the pictures. So we're looking at flooding. So as you can see in these pictures, we can see some of the effects of flooding. We've got the street all completely flooded in the first picture here. We've got these cars damaged and the buildings in the background in the second picture. So we need to be aware of what the different causes and effects are of extreme weather in the UK. So in that news article, you should have seen the devastation and the problems caused by the flooding in Cumbria. So when you think about where Cumbria is, first of all, so Cumbria is what we call a county. It is like a district of the UK with its own council, and it's right up in the northwest of England. You can see the star right here. It's quite a large county, but a lot of it is countryside, and being so far north, it gets quite a lot of rain. If we look a little bit closer at Cumbria, we can see the main towns that were affected. So we've got this town here called Workington, and we've got another town called Cockermouth. Cockermouth is the one we're looking at. That's the one that was most badly affected. You might be able to see on the map, you've got some lakes around here because this is the Lake District. So there's obviously a lot of water in the mountains, and it's what happened, what caused it to flood in 2009. So one of the places badly hit by flooding was Cockermouth. So you can see it here where all the flood warnings were. This is a small market town, so it's not a very busy town, with a population of about 7,877. The flooding hit in 2009. So this is a map of Cumbria and showing all the towns in 2009 that had flood risks, Cockermouth being one of them. What were the causes of the flooding? So there was a massive downpour of rain. So they had over 30 centimetres of rain over 24 hours. It doesn't sound like much, 30 centimetres, like a ruler, but imagine that amount of rain spreading over miles and miles of mountainside. So that was a lot of rain to come quite quickly. The other thing was Cumbria had already received a month's worth of rainfall. So the ground was already very, very wet, already waterlogged. So new rain couldn't soak in. Because it's in the mountains, the rain flowed down the steep slopes of the Lake Districts into its rivers, taking about 36 hours to get in there. There was also something called a deep Atlantic Ocean depression moving northeastwards over Scotland and northern England. So that's when you get a lot of wet, rainy weather, stormy, wet weather. And there's two rivers, the River Derwent and the River Cocker, had already swollen with previous rainfall. So these rivers were already very, very full, and then there was a lot of rain, which meant it flooded. And we'll have a look at a little diagram of that in a second. So this is a very simple diagram of what Cockermouth looks like. So Cockermouth would be this small village right here. This is the Atlantic Ocean right here, and this is the Lake District. These are the mountains. So let's just have a quick look at what happened in the Lake District. So first of all, we had this conveyor of very warm, moist, subtropical air being carried towards Britain. This was the depression, so it was bringing a lot of wet air with it. That warm air rose over those mountains in Cumbria, the Cumbrian mountains. They cool down and condenses, causing a lot of rainfall. This rainfall then fell for 24 hours. The heavy rain managed to enter all of the rivers and the sea, so it got in there over a period of 36 hours. And the increased amount of rain coming into the sea, combined with that warm air carrying more rainwater, it all entered the river in Cockermouth, both of them, the Derwent and the Cocker, and caused a lot of flooding. So that's the causes of the flooding. Let's have a look at the effects.